Okay, I'm going to talk to you guys a little bit about electron domain geometry within different atoms and just kind of talk about what's going on with them. So first, let's just start with what an electron domain is. So electron domain geometry is the arrangement of electron domains, or like the bonds and the lone pairs around a central atom. So we want to make sure that we have that definition and distinguish that against molecular geometry. Molecular geometry is the arrangement of the bonded atoms. So those two can be easily mixed up, but they're obviously different things. So here I have a model of a trigonal planar electron domain. So a good example of this could be sulfur dioxide. It has a total number of 3 electron domains, so each balloon here is a different domain. And then there's also one lone pair within these. So that's a trigonal planar electron domain. Then the next one we have would be a tetrahedral electron domain. We have 4 different electron domains considering the tetra part. So with a domain like this, we would have we could have 1 or 2 different lone pairs in this. The 2 different examples that I have for a tetrahedral electron domain would be like NH3 or ammonia and water. With ammonia, that one has 1 lone pair, and ammonia has 1 lone pair, and then water has 2 lone pairs, but they both still only have 4 electron domains. And then where we can talk about where the difference is between electron domain and molecular geometry is, since they're both tetrahedral, the ammonia has a trigonal pyramidal molecular geometry, whereas the water is a bent molecular geometry. So that's where we can tell that those things are different. We have here another form, which would be the trigonal bipyramidal. So this one, as we can see, there's 5 different electron domains within this. So here we can still have anywhere from 1 to 3 lone pairs. So a couple examples I have that would be included within the trigonal bipyramidal would be sulfur tetrafluoride, chlorine trifluoride, and then IF -2. And again, all of them just have 5 electron domains, different number of lone pairs, and they're all 3 different molecular geometries. SF4 would be the seesaw-shaped molecular geometry, whereas CLF3 would be T-shaped, and the IF2- would be the linear. So although same electron domains, different molecular geometries, so it's really important to distinguish between those. Now another one that I have here is a little bit more complex. This one I have the octahedral. It's a little bit harder to see. But with the octahedral, there is surprisingly 6 electron domains between this. So when you hear octahedral, you would probably think of 8, but in this case, there's only 6, and we have 2 different types of examples with this. We have the bromide pentafluoride, as well as the xenon tetrafluoride. So again, we can have anywhere from 1 to 2 lone pairs with this. But the main thing with the electron domain geometry is to know that this is where we can have a bonded or lone pair around a central atom. Those are all the orbits that can be within that. So all of these models that I showed you, right here in the middle is where we have our central atom, and this would just be where one lone pair or electron pair would be. So just remember that we need to be able to distinguish clearly between electron domain geometry and molecular geometry, because they can be in the same electron domain but have different molecular geometries.